Factory defects. Why melted chocolate saved the confectionery industry. The mistake that made history. Hold a Lindt chocolate bar in your hand right now. It melts smoothly, luxuriously on your tongue. But did you know that this perfect melting was considered a catastrophic factory defect for decades? In the 19th century, all solid chocolate was rough, dry, and sandy in the mouth. Chocolatiers fought against an invisible enemy, defective cocoa butter crystals that made chocolate grainy and unpleasant. The industry faced an existential crisis. Chocolate was an elite product that nobody truly loved eating. The texture was so bad that people preferred chocolate only as a beverage. And then, on a Friday evening in 1879 in Bern, Switzerland, a confectioner named Rudolf Lindt made a mistake that would change everything. He forgot to turn off a machine. The chocolate kept beating, melting, being tortured for 72 consecutive hours. On Monday, upon returning to the factory, Lindt found something impossible. Chocolate that melted perfectly, that shined intensely, that had a flavor never before experienced. The defect had become the feature. This is the moment when melted chocolate saved the confectionery industry, the technical impasse. The problem haunting the chocolate industry had a terrible scientific name: unstable polymorphic crystallization. Cocoa butter, the fatty heart of chocolate, could crystallize in 6 different forms. Only one of them, form V, was stable enough to create chocolate with shine and pleasant texture. But achieving this perfect crystallization was practically impossible with techniques of the time. When chocolate solidified naturally, it formed large, irregular, and unstable crystals. The result was the nightmare known as fat bloom. That whitish, greasy layer that migrated to the surface. The chocolate became gray, dull, too brittle or too soft. Worse still, it melted in hands before even reaching the mouth, or refused to melt completely, leaving a sandy and unpleasant sensation. Chocolatiers tried to control temperature obsessively during the tempering process. They melted chocolate at 45 degrees, cooled to 27 degrees, reheated again. But a small temperature error, an air fluctuation, a climate oscillation was enough, and the unstable crystals returned to form. It was a losing battle against molecular physics. Solid chocolate remained an inferior product, defective by nature. The intentional error. Rudolf Lindt wasn't trying to revolutionize chocolate that Friday in 1879. He was simply exhausted after months of failed experiments. His small confectionery in Bern produced the same bitter, hard, and sandy chocolate that all other manufacturers made. But Lindt was relentless, almost obsessive in his quest for something better. He had created a strange machine. A large shell-shaped container with granite cylinders that moved the chocolate back and forth. It was a violent, prolonged mixing that nobody else was doing. But Lindt was relentless, almost obsessive in his quest for something better. That night, after another round of tests, Lindt simply went home without turning off the machine. It wasn't a planned experiment, it was a memory lapse, forgetfulness, pure human error. The machine beat throughout Friday night, continued beating on Saturday and on Sunday. For 72 uninterrupted hours, that chocolate mass was mechanically tortured. The chocolate melted, partially cooled, heated again from constant friction. The cocoa butter crystals were broken, regrouped, broken again thousands of times. Moisture slowly evaporated. Unwanted volatile compounds were eliminated by constant movement. And throughout this accidental process, something miraculous was happening at a molecular level. The crystals were reorganizing into the perfect form. The doubt and the resistance. On Monday, when Lindt returned to the factory and saw the transformed chocolate, he didn't celebrate immediately. He was confused, skeptical, almost frightened. The chocolate had completely changed. The texture was smooth as silk. The color had a deep shine never seen before, and when he tasted it, it melted instantly on the tongue with intensely superior flavor. But this contradicted everything the industry knew about chocolate. Chocolate shouldn't melt so easily. It was considered a sign of instability. Excessive shine was suspicious. And that smooth flavor, without harsh bitterness, seemed unnatural. Lindt repeated the process several times in secret, confirming it wasn't an illusion. But when he finally began selling his fondant chocolate, the industry's reaction was scorn and mistrust. Other chocolatiers accused Lindt of adding wax or paraffin to create that false shine. Consumers accustomed to hard, bitter chocolate found Lindt's product too soft, too melted, artificial. Sales were modest, limited to curious customers willing to experiment. Lindt kept the conching process in absolute secrecy, operating only at night so no one would steal his technique. For almost 20 years, he worked alone, perfecting the method the industry refused to accept. Melted chocolate remained a defect, even being clearly superior. The great revelation. In 1899, everything changed. Johann Rudolf Springly, one of the most powerful chocolatiers in Switzerland, finally tasted Lindt's chocolate after 20 years of refusal. The experience was transformative and immediate. Springly recognized that this defect of perfect melting was, in fact, the characteristic that made chocolate irresistible. He offered to buy Lindt's entire company for 1.5 million gold francs, an astronomical fortune for the time. But the price included something even more valuable, the secret of conching. Lindt accepted with the condition of maintaining a voice in the business. The Lindt and Springly partnership was born, and conching finally emerged from the shadows to revolutionize the global industry. The technical revelation was explosive. The prolonged conching process did three simultaneous things that nobody had understood. It mechanically broke defective cocoa butter crystals, forcing them to reorganize into stable form Vi. It eliminated moisture and bitter, volatile compounds that ruined the flavor. And it uniformly incorporated cocoa butter with cocoa sugar and milk, creating a perfect emulsion. The resulting chocolate melted perfectly at 32 to 34 degrees, exactly the temperature of the human mouth. The defect of melting was, in fact, perfect molecular engineering. In less than a decade, Lindt and Springly became a world leader, and conching began to be used by all premium manufacturers. Chocolate had finally evolved from a bitter beverage to the irresistible solid form we know today. The consequence of success. The spectacular success of conch chocolate created a new problem nobody had foreseen: the industrial tempering paradox. Lindt and Springly and their competitors now produced tons of perfect melted chocolate through conching. But when this chocolate was cooled and solidified on a large scale to create commercial bars, the same old demons returned. Fat bloom, whitish surfaces, loss of shine. Conching had solved texture and flavor, but not stability during mass solidification. Perfect melted chocolate became imperfect again when solidifying. Factories now needed to apply the tempering process, those precise cycles of 45 degrees C, melting, 27 degrees C, cooling, reheating, on a gigantic industrial scale. Any minimal temperature fluctuation in the production line ruined entire batches. Chocolates arrived at stores with a stained grayish appearance without the promised shine. Worse, during transport and storage, thermal oscillations caused fat migration to the surface. Consumers complained about spoiled, moldy chocolate with repulsive appearance. The industry faced a new factory defect. Chocolate that melted perfectly in the mouth also melted easily during distribution. Ironically, Lindt's solution had created a product so sensitive it was difficult to transport and sell. The expanding chocolate market of the 1900s-1920s was threatened by this second critical defect. Public crisis and the scandal. In 1920, the rotten chocolate scandal exploded in the European press. Newspapers published shocking photos of chocolate bars covered with grayish-white spots that looked like mold or decomposition. Consumers reported symptoms of psychological poisoning, nausea, disgust, upon seeing chocolate with the appearance of spoiled food. Lindt and Sprüngli and other manufacturers were accused of selling expired or contaminated products. Doctors warned parents not to give chocolate with white fungi to children. The elegant remedy. Salvation came from an unexpected source: the in-depth scientific study of crystal physics that Lindt had accidentally manipulated decades before. In the 1930s, physicists and chemists finally deciphered the exact science behind conching and tempering. They discovered there were not only 6 forms of cocoa butter crystals, but precise methods of controlling which form would develop. The solution was 3-stage temperature control, rigorously calibrated. First, completely melt the chocolate at 45 degrees C to destroy all existing crystals, good and bad. Second, rapidly cool to 27-28 degrees C, temperature at which only stable form Vi crystals begin to form. Third, slightly reheat to 31 to 32 degrees C, melting unstable crystals but preserving stable ones. This process, called scientific tempering, transformed melted chocolate into bars with perfect and permanent crystallization. The marble tablage technique emerged as an elegant artisanal method for small batches. For industrial production, automatic tempering machines were developed that controlled temperature with precision of tenths of a degree. Brazil contributed decades later. In 2016, Unicamp developed ultrasonic technology that accelerates tempering and prevents fat bloom using molecular vibrations. The melted chocolate that Lindt had accidentally created now had the perfect complement: scientifically controlled solidification. The original defect was tamed by precision engineering. The remedy was as elegant as the problem: accept the melting, but control its reverse. The philosophical legacy. The story of melted chocolate reveals a profound truth about innovation. The greatest advances frequently come from embracing defects instead of avoiding them. Rudolf Lindt didn't plan conching. He forgot it running. Chocolate that melted too easily was considered defective by the industry. But that perfect melting at 30 degrees was exactly what made chocolate irresistible on the human tongue. The defect was the disguised feature. Today, every premium chocolate bar in the world is a direct product of that 1879 era. Lindt and Sprüngli has become a global giant of 4 billion francs, present in more than 120 countries, all based on chocolate that melts too much. The conching technique, originally a weekend accident, is now exact science taught in chocolate schools worldwide. The second defect, the fat bloom from industrial solidification, forced development of scientific tempering that benefited countless industries beyond chocolate. The philosophical lesson resonates beyond confectionery. Factory defects frequently signal not design failure, but misunderstanding of possibilities. The sandy chocolate of the 19th century wasn't the ideal final product, it was just the limit of understanding at the time. Lindt didn't correct chocolate. He redefined what chocolate should be. The industry didn't need chocolate that wouldn't melt. It needed chocolate that melted perfectly at the right moment. The mistake that made history teaches us that true innovation often means recognizing that the defect is, in fact, the future knocking at the door. Factory defects. The chocolate you savor today exists because a Swiss confectioner forgot to turn off a machine. The perfect melting that defines premium chocolate was considered a catastrophic defect for decades. Rudolf Lindt transformed 72 hours of accidental error into a 150-year industrial revolution. Conching was born from forgetfulness, not from planned genius. The fat bloom that almost destroyed the industry in the 1920s forced the development of scientific tempering that today guarantees worldwide quality. Every Lindt bar sold, and they are billions annually in 120 countries, is a direct descendant of that defective chocolate from 1879. The mistake that made history teaches us that true innovation frequently means recognizing that defects are misunderstood features awaiting revelation. Melted chocolate saved the confectionery industry by proving that melting wasn't weakness, but molecular perfection calibrated for the human tongue. If you'll never look at chocolate the same way again, leave your like, subscribe to discover how history's greatest successes were born from catastrophic errors that nobody planned. Comment, what defect in your life could actually be your greatest feature? Share with someone who needs to rethink their own factory defects.